don't have to write this down. Just watch. Maybe we'll
Sorry
write
for the
down.
interruption. Would all grade 11 students with the last names beginning with M through R please go to the gym for your picture? That's all grade 11 students with the last name starting with the letter M through R. Please go to the gym for your picture. Thank you.
If you're in the grade 11 and those are your last initials and you haven't had your picture taken, you need to go down to the gym. This is on video, so you'll be able to see it afterwards. So what I'm going to just do here is, this is super busy, okay? But I'm going to color code things here. Can you see that the red one is your absolute value of x? Now, if we just had a 2 inside, that would multiply your x by a half, because it's inside the absolute value and x is our lives. So that would cause it to have horizontal compression and squish it towards the y. Can you see the blue one is squished in? Then, color coding wise, they went next to green. This one is the green one. And now your x has been multiplied by a half and your y by a quarter. So it squished it horizontally first and then squished it vertically, which I guess because the vertical squish was more, ended up with the green graph. Next we have our orange graph. Oh, I thought I saved my orange. The other day, I thought I made a new orange pen and saved it. I don't know. Anyway, orange pen, right here. Oh yeah, I remember doing this yesterday too. Saying, I don't like black ink. Say it again. There's the orange one. That has the y by a quarter, the x by half, and then also moving it 3 to the left. Can you see that the orange one is just the green one shifted 3 to the left? They did everything that the green one did, and then moved it 3 to the left. And then finally, the final graph here is the purple one. It multiplied your y by a quarter, your x by half, moved 3 to the left, and after that orange one, it moved it 4 units up. And what's going to happen is you are going to be asked to, I want to make another thing. Let's do this one. So this is what I want you to write down. I want you to think about that purple one, so I'm going to write it in purple. Y equals 1/4 absolute value 2 x plus 3 absolute value plus 4. And we have a lot of things going on here, so I'm going to label them. This one, vertical compression. Vertical compression says you should multiply your y values by 1/4. This 2, horizontal compression. You multiply your x values by 1/2. The 3, horizontal translation. We're going to go 3 opposite, 3 to the left. And the 4 is a vertical translation, 4 up. So that's very shorthand right there. But at the end of this question, they did have the word describe again. So this would be quite the thing to describe. Describe how the graph is related to the graph of the original graph. So you would have to write out in words, there we go, everything that we see. The graph of y equals the absolute value of x would have a vertical compression. This is going to be annoying to write up. Most math people get annoyed by the describe and explain questions, because we're not English people. We don't want to write big, long sentences. Okay, so the graph would have a vertical compression by a factor of 1/4. Ooh, I think this might actually be a place in the English language where you could officially use a semicolon, but don't quote me on it. Would have a vertical compression of a factor of 1/4, a horizontal compression by a factor of 1/2, horizontal translation three units left, and a vertical translation four units up. Whew. And you're going to be asked to graph these things with all of these things happening. And there are a couple of other options. Option 1 you probably won't use. Option 1 is graph one thing at a time until you get your final one. You're not going to want to use that because nobody likes graphing that many times. But that is an option. We could do one thing at a time, from left to right, until we get our final answer. Instead, what we're going to do is we're going to think about the original graph, which was the red one. I'll just redraw it here for a second. And obviously, this is the most important point on the absolute value graph. But we could take a few other ones as well. Now, the absolute value is probably the easiest one to grab lots of points on, because it's so easy, because the x value and the y value are the same on the right. And then on the left-hand side, it's like -1, -1, -2, -2, -3, 3. It's easy to grab points. I would probably, if I was doing this question, I would probably grab and see if you can see why. Why would I probably choose these as my 2 points? One graph. Instead of 3, 3, or instead of 2, 2, instead of 1, 1. Yes.
Because you're multiplying by 1/4, so you can do that easily with 4.
Yeah, I'm going to multiply my y's by 1/4. So to avoid a fraction, the 4 seems like a nice one to do. And we showed this work a little bit before. You know when I listed the points, the original points? But now that we have so many things happening, I like to do it I guess it was a purple graph in the end. I like to do it in 2 stages. I like to do all my stretches, compressions, and reflections first, and then all my translations second. Because if we look at what we wrote out, we have 2 things that affect it vertically. We have a vertical compression, and we have a vertical translation. We have 2 things that affect it horizontally. A horizontal compression and a horizontal translation. And the order matters. We have to, just like reading, you have to go from left to right. And the compressions and stretches always happen before the translation. So when I set this up, maybe I'll just make a note here. This is stretches, compressions, reflections, and this is translations. And this is always first, and this is always second. A favorite exam question is, what did Timothy do wrong? This is what he did, and he always does the translations first. And then he did the stretch a second. So a very typical, and it's not always typical, the other just picking random names. That would be really kind of interesting if historically the exam always used the same name for making a mistake for years and years. Okay, so what does this mean for us? Well, what I would do is above the first set of arrows, I'd go through my compressions here, and I would write, I need to multiply my x by a half and my y by a quarter. I like to write my x on top because my x is my first coordinate. You don't have to, but you have to make sure you do the right thing to the right number. Makes kind of sense. You do the wrong thing to the wrong number, your answers are going to be completely off. And it's very easy to do. So if I multiply all my x's by half, I'll have 0, minus 2, and 2. If I multiply all my y's by a quarter, I still have 0. I have 1, and I have 1. Next, above the next set of arrows, I'll write my translations, and 3L for U, 3 to the left, minus old purple, minus 3, minus 5, minus 1, and 4 up, 4, 5, 5. So on my graph, I'm going to label the point -3, 4, -5, 5, and -1, 5. So in this situation, I just need my original red graph, and I can draw my final purple graph all at once instead of drawing all the ones in between. So when we have all of these things combined, that's our plan. And I find that these arrow diagrams, they help us do one step at a time. Some people like to try to do it all at once, but a single mental math error can cause a lot of marks being taken off. Because generally what they do on the exam is they just look at your graph. And they look, do you have the 4 things? And if all 4 of your things show up, you get a mark for each of them. This is a 4-mark question on the exam. It seems a little bit high, but they give 1 mark for each transformation. Okay, so with that, we are ready to go to example 1. And here's the graph of g of x. We want a vertical compression by 1/3 and a translation of 2 units up. So if I was doing the points thing, I have 4 key points here. I'm going to label them all. I have -5, 3, -2, -3, 1, 0, and 4, 6. And if I set things up, and again, I know you probably could do this with just 1 set of arrows because there's not too much happening in this question, but I like to always get into the habit of doing my compressions first. So the vertical compression by a factor of 1/3, when they write it out in words, that's exactly what you're multiplying by. Whenever they say, if they say horizontal by a factor of 2, your x is multiplied by 2. So when they say the words, there's no longer liars. If they say it moves 3 to the left, you're like, no, you're lying. It moves 3 to the right. No. In words, they never lie. It's just in the equation. that the x's are letters. And then we're going to be 2 units up, so that would happen here. So first of all, my x coordinates are not changing, so this is relatively easy to write those ones down. But now my y values by 1/3, this will be 1, -1, 0, and 2. And then 2 up will be +2, will be 3, 1, 2, and 4. And I did that fast, and what you didn't notice, because I did it in my head, is after every single one that I did a quick double check. Because it is so easy to make a little mental math error here. And if you make a little mental math error, you go to draw your graph, it looks completely funny, and then you don't know where you made your mistake, and then you have to check everything again. So do little mental math checks along the way. It's not hard to +2 to numbers, but you'd be amazed how often you make little mistakes when you're doing that much mental math. So now, we can go. -5, 3. I'll put my final graph in purple. -5, 3. Oh, that point ended up in the same place it started. -2, 1 is there. 1, 2 is there. And 4, 4. Connect your lines. Does it look like it was compressed vertically, squished towards the x-axis? And then does it look like it would have been shifted up afterwards? So another thing you can do is sort of a check. You can think about the transformations and just sort of mentally go, does it look about right? Is my shape about right based on those kind of things happening? Okay, circle questions 4, 5, and 6. Oh, and we are also, I'll get you to circle 4, 5, and 6. But in this example, we are also, I want to point out something special that happens in example 1. In fact, maybe I'll quickly, before we do that, I'm going to quickly go back to this one. And in terms of G, the purple graph would look like this, right? You'd have a 1/3 out in front of the equation, right? And then a +2 after the equation as well. Because vertical is always outside. So if I wanted to label this purple graph with an equation, that's what the equation would be. Now we have to be a little bit careful with horizontal stuff, and I'll show you why in a second. So this one wants, you don't have to write any of this down for this question because it's all done for you. But if I took the 4 points, so -4, 3, 0, -2, yeah, just watch so you can see if you can, it makes sense to you as we're going along. This one's all horizontal. And normally I don't do the second example, but something interesting happens in this question. So, we want a horizontal compression by 1/2, that's x by 1/2, 3 units to the left, put that one second. And so my y values never change. My x values by 1/2 will be -2, 0, +1. And then 3 to the left, this will be -5. This will be -3, -2, -1. And we could draw those points. So -5, 3, I'll do it in purple. -5, 3, -3, -2, -2, and 5, and finally -1 and 2. Connect the dots. And look, does it look like it's compressed and moved to the left? Yes, that looks like the right equation. Now, where horizontal gets, I think this is probably one of the trickiest things in Unit 1. Where the horizontal gets tricky is the following. When I go to write this equation, sometimes the following two are the most common answers. And you have to tell me which of these two common answers is the correct one. What does your gut tell you? So does your gut tell you should have, okay, y equals, everything is inside the function. My function is f, so I'm going to write f, inside, and I can either write it like this, okay, the 1/2, x's are liars, it's got to be a 2. The 3 to the left, x's are liars, has got to be a +3. And there has to be an x in there. So these are your options. Do you write it as 2x + 3 or 2x + 3? With an extra set of brackets or without an extra set of brackets? Ooh. Right? Because right now, most of you would be like, I don't know. Okay? One of them is right. You could look at the very first example we did in the Construct the Understanding and check that one. Did it have extra brackets or did it not? Okay? Maybe you like x's are liars. Which one looks nicer? The one without brackets. So which one does it have x's are liars? It's got to be the one with extra stuff in there. So this one is wrong, and we are going to, and I'll get you to write this at the bottom. The bottom of the page here, we're going to write a special note to remind us. And this only happens with horizontal. When you have a horizontal stretch / compression and or / reflection and a horizontal translation. You must write the equation must be written in factored form. You must factor out whatever the number is, the horizontal stretch number, compression number, or negative, has to be factored out. So again, we're talking back at Timothy making a mistake. Also, very fun example. They'll give the purple that I have the X through. And they'll say, Timothy described the transformations as a horizontal compression by a factor of 1/2 and a translation of 3 units to the left. Describe Timothy's error. Okay? And if they give you one of those questions on the exam or on one of my tests or take-home quizzes and they say describe the error, and you write there is no mistakes, they're not trying to be tricky. They're never going to say describe the error and be like, haha, there is no mistake, see if they catch on. No. If they say describe an error, there will be an error there. And the error is that Timothy should have written it in factored form. If it's this way, then it's 3 to the left. Technically, this one that I put the red line through, if I factor out the 2, that second one with the line through is actually a translation of 1.5 units or 3/2 units to the left. not 3 units to know. This is the #1 mistake on your first unit test. It comes up like 3 or 4 times on the first unit test, and like lots of people miss it. There'll be a multiple choice question, they'll be like, none of the answers work. I'm like, you're forgetting the factored form thing. I can't say that on the test, but I'm like, that happens a lot. Okay? So much that one year I had a student set a reminder in their phone for 10 p.m. every night. And at 10 p.m. every night their phone went bling, and this came up. And they say, oh yeah, I'll remember that. Now, we're going to have so many things this year that you're going to remember. If you wanted to do that as a reminder thing, by the end of the semester, you'd have probably like 2 hours of reminders starting at 10 p.m. They're just go, bling, remember this, remember this, remember this, remember this. There's a lot of things to remember. But this is the first kind of tricky one. Okay.